Okay, we're going to do one more video here, and this is just going to, it's a more involved problem that's ultimately going to use the law of cosines. There's a little more going on here, and this will help you with the last problem that's on the homework. So I put it on there to kind of stretch you a little bit here. So here's the idea. You got an observer here who is standing on, this little cliff here at this tall cliff, and it is known that the cliff is 4,680 feet. Okay, and he notices that his angle of elevation here is 47 degrees. So that means from this horizontal here, it goes up 47 degrees, and then when he looks down at the bottom of the cliff, the angle of depression is 38 degrees. And now what this is asking us is how far away is this cliff. So it's actually asking for this length here. Let's call that D. Okay, so it's kind of like we have this triangle here, and this is almost like the height of the triangle. If this is the base of the triangle, this is like the height of the triangle. Okay, but I'm going to call it D for distance. We want to find that distance away. And then I know that this side of the triangle is the 4,680 feet. That's how big this side is. I know this angle here, I can add those together. That adds up to 85 degrees total. Okay, but how in the world can I find this? I can't assume that these are just equal. I can't assume that this is splitting this in half at all. In fact, it's not splitting it in half. Okay, this angle is bigger than this angle, so there's more going from here to here than from here down there. Okay, so this is a very difficult problem to solve here. So what I'm going to do is I'm going to assign an A and a B here. Okay, and then I got this middle angle here, which is 85 degrees. And then I know this is kind of like my C. So I'm going to set up the law of cosines, but I'm going to have an A and a B in there when I do. Okay, so it would be like this. So this is like my C side, so I get 4,680 squared is equal to the A squared plus B squared minus 4AB times the sorry, not 4. I'm sorry, 2AB times, I was thinking of Pythagorean theorem or quadratic formula or something, times the cosine of 85 degrees. Right? So this is with that A and B. I'm just setting up what the law of cosines would look like. Let me zoom out just a little bit there. Okay, so now how in the world can this help me find D? Well, it can't, really. Okay, but when you have like several variables going on, oftentimes it's helpful to find other relationships and substitute them in, and use other relationships together to solve a problem. That's one reason I assigned this one, because this is a good one to really challenge you and to help you think about how to solve a mathematical problem with more than just one equation. So with multiple relationships, substituting them in and out, you can do a lot more than you could with just a single relationship. So what I'm going to do is I'm going to use these right triangles like this, because that's going to bring D in there. And so what I can do is I can say that the cosine of 47 degrees, cosine because the D is the adjacent side, the A is the hypotenuse. So this would just be D over A. And that brings in both D and A, the same A that's up here, right? And then in a similar way, I can say that the cosine of 38 degrees here is d over b. And now I'm bringing in the a and the b. Right here, I'm bringing in the d. Okay? So now what would be nice is if I could substitute this stuff in here in such a way that this is all in one variable. So here's what I'm going to do. You could do this multiple ways, but I'm going to say here d would be a cosine of 47 degrees, and here d is also b cosine of 38 degrees, and so both of these are equal to one another. They're both equal to d. So I got a cosine of 47 degrees is equal to b cosine of 38 degrees. So I got this is equal, and then I'm going to solve this for a, and then I'd get b cosine 38 degrees over a. I'm sorry, over the cosine of 47 degrees. Sorry. So what I did is I solved this for a by moving that over. Okay, and the reason for doing this is that I can now substitute the a into here, and then I got an equation where everything is in terms of b. And how that's going to help is I can then solve this equation for b, and then I can substitute it back into here and find out what d is. Okay, a very complicated problem here. So I'm going to plug this in for b here, and I'm going to need a lot of space to do this. So in for a, I get this, b cosine 38 degrees over cosine 47 degrees, that quantity squared, plus b squared minus 2, and then in for a again here, I'm going to put b cosine 38 degrees over cosine 47 degrees, and then I have a b and I have a cosine of 85 degrees. So I got all of this. Now if you look at this carefully, what you see here is that you have a b squared in each of these terms. So I'm going to rewrite this kind of like this. This 4,680 squared is equal to, and then this would be like cosine of 38 degrees over cosine 47 degrees, that quantity squared, over b squared, plus b squared, minus, and then this b and that b would be a b squared. And then I'm going to bring this with all of those, so I would get like a b squared times, and then this would be like 2 cosine of 38 degrees cosine 85 degrees over cosine of 47 degrees. Wow, all of that. And the reason I do this is I can now pull out a b squared, and then I can divide this side by everything that remains over here. So let's see if I can, I'll go ahead and write that out just to make it clear. So what I'm doing is I'm factoring out a b squared, and then I'm going to get cosine 38 degrees over cosine 47 degrees squared plus 1 minus 2 times cosine 38 degrees cosine 85 degrees all over cosine of 47 degrees. All like that. And then I can take this here divided by all that, but maybe just to make things a little bit easier, what I can do here is calculate that. see what that's equal to. Okay, and then maybe I can zoom in on this here a little bit. Okay, so there's a lot there. So cosine 38 divided by cosine 47, and that whole thing is squared, and then I'm going to add 1, and then I'm going to subtract, in parentheses I'll say 2 cosine 38 times cosine 85 divided by cosine 47. And then that whole thing is like, so this is like b squared times 2.49276, and I'll just round, I'll just keep it there. So what I get here is that b squared is equal to 4,680 squared over 2.492796. But I have it in here, so I'm going to use that expression. I'm going to just take 4,680 squared, and I'm going to divide it by the answer here, since it's already up there. And I'll click equal. And so b squared is equal to that. So now I'll take the square root of all that, and I'll get that b is approximately equal to 2,964.2 feet. And that actually is believable. It makes sense, doesn't it? If that is 4,680 feet, that's 2,964 feet. Okay, so that was a serious problem, okay? It involves overall the relationship, the law of cosines got used, but then we use these right triangles in order to substitute and get it all in one variable. And then, but you know what? That's b. Sorry, that is this distance. I'm not done. So I got one more thing. To find the actual distance now, I got to plug b into this, right? So d is equal to 2,964.2 times the cosine of 38 degrees. So basically I'm going to take my answer there and just multiply by the cosine of 38. And I get 2,335.8 feet. And again, that makes sense. That's what this is. So I found that, and then I was able to find this by using this relationship here. Okay, so that's, let me zoom out on that. Hopefully I got most of that in there. So I had to, again, I found b, I found this distance. So to find that, I used this relationship. And I just plugged this in for b times the cosine of 38. And I got the distance from here to here. Okay, so that was a pretty involved problem. And basically, the one that you're given in the homework is very similar to this. So enjoy, have fun with that, and just let me know if you have any questions.